Hello GATE aspirants, welcome to part 10 of GATE Electromagnetic Theory series. Question number 14. The electric field of an electromagnetic wave is given by E bar is equal to 3 sin kz minus omega t x cap plus 4 cos kz minus omega t y cap. The wave is. Here E is given and we can consider, let us consider that it is at z is equal to 0. So for that, this Ex component, this will be 3 and this k is equal to 0. So this will be minus of 3 sin omega t, and this Ey, this will be 4 cos omega t. So we are considering z is equal to 0 here. And let us consider first when omega t is equal to 0. So when omega t is 0, Ex will be 0 and this Ey will be 4. So this will be this will be the point. And when omega t, let us consider when it is pi by 2, then in that case Ex will be, this will be sin pi by 2, so that will be minus 3, and then Ey will be, this will be 0. So minus 3, 0, it will be this point. So this is 4 and this is minus 3. So it is going like this. So here this is going in and in this direction, counterclockwise direction, and when we are looking at like this, so this is 4 and 3. So that means it is elliptically polarized. So option D is correct here. It is elliptically polarized in counterclockwise direction when seen traveling towards the observer. So that's why we have taken z is equal to 0. Next question. An infinitely long, thin cylindrical shell has its axis coinciding with the z-axis. It carries a surface charge density sigma naught cos phi, where phi is the polar angle and sigma naught is constant. The magnitude of electric field inside the cylinder is. Now for this we will consider some line charge. So this dE, this will be equal to, we have formula 1 upon 4 pi epsilon naught, and electric field due to this, if we are considering infinitely long wire, then in that case E is equal to, the formula is 1 upon 4 pi epsilon naught 2 lambda by r, where this lambda is linear charge density and r is distance from it. So at this point we can calculate E. So we will use this formula, but this is a cylindrical shell. So for shell we will consider a small portion of it and let it be d lambda. This will be 2d lambda whose radius is r. So this will be equal to, this 2 and 2 will cancel out. This will be 2 pi epsilon naught into r into we have d lambda. Now here surface charge density is given, that is sigma naught into cos phi. Now surface charge density is equal to charge upon area, out of which charge upon length is lambda. So this will be lambda by length. So lambda is equal to sigma into L. So d lambda will be sigma into dl. So d lambda is equal to sigma into dl. We will use this. Now sigma is rho naught into cos of phi, and d lambda, that will be equal to r into d phi. So this is equal to sigma naught into cos phi upon 2 pi epsilon naught, this r and r will cancel out, into we have d phi. Now dEx, it will be x component, and x component is cos theta component, so that will be dE into cos theta, that will be equal to sigma naught upon 2 pi epsilon naught. Then we have cos phi into this cos phi, let me take here cos phi. Cos phi into cos phi, that will be cos square phi d phi, and limit is from 0 to 2 pi. So this will be equal to sigma naught upon 2 pi epsilon naught, and this will be equal to pi. So that is equal to sigma upon 2 epsilon naught. So here option B is correct. Here you can use that formula, cos 2 theta formula, and then integrate this. This comes out to be pi. Next is question number 19. A circular loop made of a thin wire has radius 2 cm and resistance 2 ohm. It is placed perpendicular to a uniform magnetic field of magnitude 0.01 Tesla. At time t is equal to 0, the field starts decaying as B is equal to B naught e raised to minus t by t naught, where t naught is 1 second. The total charge that passes through a cross section of the wire during the decay is Q. The value of Q is. Now induced EMF is equal to minus d phi by dt, which is equal to minus A dV by dt. Here it is given that B is equal to B naught e raised to minus t by t naught. So this will be minus A, and here we have B naught. Derivative of this with respect to t, so that is e raised to minus t by t naught into minus 1 by t naught, which is equal to A B naught upon t naught into e raised to minus t by t naught. Now current is equal to E by R, so that will be equal to minus A B naught R T naught e raised to minus t by t naught. That will be current. Now Q is equal to integration from 0 to infinity I dt. So this will be equal to integration. These terms are constants. So this is positive here. So this will be equal to A B naught upon R T naught, and integration of this. So this will be e raised to minus t by t naught upon minus 1 by t naught, integration from 0 to infinity. So this will be, this t naught and t naught will cancel. This is with minus sign, and e raised to minus infinity is 0 minus 1. So this will be A B naught upon R only, and area is pi r square. So pi r square into B naught upon R. So Q is equal to pi into r square. Radius is 2 cm, so that will be 4 into 10 to the power minus 4. B naught is 0.01, so that is 10 raised to minus 2 upon R, that is 2. So this will be 2 pi into 10 to the power minus 6 Coulomb, and 2 pi is 6.28, 10 raised to minus 6 is microcoulomb. So answer is 6.28, and answer in the answer key is 6.26 to 6.30. The electric field of an electromagnetic wave in vacuum is given by E bar is equal to E naught cos 3y plus 4z minus 1.5 into 10 raised to 9 t x cap. The wave is reflected from z is equal to 0 surface. If the pressure exerted on the surface is A epsilon naught E naught square, the value of A is. So here k bar is equal to, this is the part, so this will be 3y cap plus 4 z cap. Now in the z direction it is 3, and in the y direction it is 4. So from here we can calculate the angle between these. So this angle, if you consider theta, then this will be side phi. Now P is equal to, formula is I by C into 1 plus R into cos of theta. So this will be equal to, I is equal to 1 by C. So I is equal to 1 by 2 into C into epsilon naught into E naught square into 1 plus R into cos theta. So this C and C will cancel out. We have 1 by 2 into epsilon naught into E naught square, and here it is reflecting from the surface, so R is 1. So this will be 1 plus 1, so 2 into cos theta. So cos theta will be here 4 by 5. So this 2 and 2 will cancel out. So this will be 4 by 5 epsilon naught into E naught square, and 4 by 5 is 0.8 epsilon naught E naught square. Answer is 0.8. Answer in the answer key is 0.8 to 0.8. Next, question number 29. A solid cylinder of radius capital R has total charge Q distributed uniformly over its volume. it is rotating about its axis with angular speed omega, the magnitude of total magnetic moment of the cylinder is. Now we know di is equal to, current is equal to dq by t. Now t is equal to 2 pi by omega. So this can be written as dq upon 2 pi into omega. Now dq is charge in that portion. So we can write it in terms of volume charge density. Now volume charge density is equal to dq upon v, whatever that volume is. So dq is equal to rho into dv. So this is rho dv into omega upon 2 pi. This is current. Now because of this current, magnetic moment is equal to current into area, so into pi r square. So this will be equal to rho into, we have pi r square, and this value we will substitute here. So rho into omega into pi r square upon 2 pi into, we have dv. So this pi and pi will cancel. So d nu is equal to rho omega into, we have, this is small r square upon 2 into d omega, dv, sir. That is volume element. Now total will be, we will take volume integral on both sides. So this will be rho omega by 2 integration of r square. Let us consider polar coordinates. So this will be r dr d phi dz. That is volume integral. So this will be rho omega by 2 integration r cube dr. So from here mu is equal to rho omega by 2, then it will be r cube dr. R is going from complete volume, so this will be 0 to capital R. Then we have d phi. Phi goes from 0 to 2 pi, and dz, and dz goes from z goes from 0 to L. So this will be rho omega by 2. This will be r raised to 4 by 4 into 2 pi into L. Now rho can be written as, rho is equal to charge upon volume. So rho is equal to charge, total charge is q upon total volume is volume of that cylinder, that is pi r square L. So this will be q upon pi r square L into omega by 2 into r raised to 4 by 4 into 2 pi into L. So L will cancel, 2 will cancel, pi will cancel, and r square will cancel. This will be q into omega into r square upon 4. So here option C is correct. 1 by 4 q r raised to 2 upon 4. Next question. 37. In a set of n successive polarizers, the mth polarizer makes an angle m pi by 2n with the vertical. A vertically polarized light beam of intensity I0 is incident on two such sets with n is equal to n1 and n is equal to n2, where n2 is greater than n1. Let the intensity of light beams coming out be in1 and in2 respectively. Which of the following statements is correct about the two outgoing beams? Here, if first, you can substitute value of m here. So first will be pi by 2n, next will be 2 pi by 2n, next will be 3 pi by 2n, and so on up to last will be n pi upon 2n. So this will be pi by 2, last one will be pi by 2. Now formula is I is equal to I0 into cos square theta, where theta is angle between two polarizers, two successive polarizers. Now difference here will be pi by 2n in each case. So this will be I is equal to I0. From the first polarizer it will be I0 by 2. Then from the next polarizer it will be cos square, and that will be pi by 2n into cos square pi by 2n, and so on into cos square pi by 2n. So this will be m minus 1 times. This will be n minus 1 times. So that means I is equal to I0 by 2 into cos of pi by 2n. This thing raised to n, and also square is there. So this thing raised to 2 raised to n minus 1. This many times it will be there. That means it is depending on n as well. Now here it is given, if in2 is greater than in1, then polarization is vertical or horizontal, that we have to calculate. Now if we consider if the number is large, that means if n2 is greater than n1, then that means more polarizers are there, and with more polarizers the change is more gradual. So if change is more gradual, then more light is transmitted. So in that case intensity will be larger for n2. Here it is given n2 is greater than n1, so that means intensity of n2 will be greater than intensity of n1, because this change will be more gradual and more light will be reflected, more light will be transmitted through those polarizers. And for the last polarizer we are getting this to be pi by 2. This is pi by 2. So the separation or the orientation of that last polarizer is pi by 2. So light is then horizontally polarized. So here option C is correct, that is in2 is greater than in1 and polarization in each case is horizontal. Next, question number 39. An infinitely long wire parallel to the x-axis is kept at z is equal to d and carries a current I in the positive x direction above a superconductor filling the region z less than or equal to 0. The magnetic field B bar inside the superconductor is 0, so that the field just outside the superconductor is parallel to its surface. The magnetic field due to this configuration of point is. Here we have to find magnetic field. Now here magnetic field is 0 because it is superconductor. That means just at this boundary, if we consider this z is equal to 0 or this d is equal to 0, then in that case this b should be 0. So we have to consider that only, that b has to be equal to 0. So in these options we can put d is equal to 0 and then answer should be 0. So for the first option, this mu naught upon 2 pi part, this is common to all options, so we won't check that. It is non-zero anyway. So for the first case, this is minus of z. So at place of d we will put 0. So this will be minus of z into j cap plus y into k cap. Upon this denominator is non-zero, so this won't be 0. For the second option, here we have minus z. This is minus z into j cap plus yk cap upon we have y square. If d is equal to 0, then this will be y square plus z square plus this will be z j cap minus yk cap upon y square plus z square. Now this will be equal to 0. So for option B, we are getting b is equal to 0. So that is correct. Next question. The vector potential inside a long solenoid with n turns per unit length and carrying current I written in cylindrical coordinates is a bar function of s phi and z mu naught ni by 2 s phi cap. If the term mu naught ni by 2 s alpha cos phi phi cap and beta sin phi s cap, where alpha and beta is not equal to 0, is added to A, then magnetic field remains the same if. So here it is given A bar is equal to mu naught ni by 2 s into phi cap. So for this case we can calculate curl of A. Now this is phi cap term. So A phi is equal to, A phi is not equal to 0, other terms are 0. So this will be 0, only phi term will survive. So these terms will be 0. So we have to consider only this. Now this is dou of dou z. Here there is no z term, so this will also be 0. So only this term will survive. That is 1 by s into dou by dou s of mu naught ni s by 2. And this will be in direction z cap. So this is 1 by s, dou by dou s of this is mu naught ni by 2 into z cap. Here we also have s multiplication here, so that also we have to consider. So this will be s square, so that will be 2 into s. So this s and 2s will cancel out, so this will be mu naught n I into z cap. That is curl of A in the first case. Now even after adding this has to be same, so we will do this. So curl of A for the second case, it will be, now let us use the formula. Formula is 1 by s into, here we have r cap, r phi cap and z cap, dou by dou r, so I will use s here, dou by dou s, dou by dou phi and dou by dou z. Now this term is added to it. Now first term was z cap term and then phi cap term, and in this is added. So this will be mu naught n I, that we can take common. So mu naught n I by 2 is, we are taking it common. Now first term is this phi cap, here we have s only, plus this term. So this will be s into beta into sin phi here, and here it will be s square into, we have alpha cos phi, and plus this original term, that will be s into s square, and this will be 0. So this is equal to mu naught n I by 2s into s cap into, this will be 0, s phi cap into, this will be again 0, z cap into, we have dou by dou s of this, so this will be 2s alpha cos phi plus 2s minus this minus of s beta, and derivative of sin phi is cos phi, into z cap. Now this will be equal to mu naught n I z cap. So this will cancel out, z cap same direction, 2s will cancel out, so upon we will have 2s. So we just have to compare this. So we have 1 is equal to alpha cos alpha minus here beta cos phi, s will cancel, so this will be beta cos phi upon 2. This is cos phi only. Okay, so this is the case. Now we have to calculate alpha and beta. One more here, plus 1 term is there, so this 1 and 1 will cancel out, so we will get alpha cos phi is equal to beta by 2 into cos phi. So that means from here we will get alpha is equal to beta by 2. So here option D is correct. Next question. Consider a system of 3 charges as shown in the figure below. For r is equal to 10 meter, theta is equal to 60 degree, and d is equal to 10 raised to minus 3, the electric dipole potential in volts is. Now for this we will consider first monopole moment. So monopole moment is equal to summation over q. So we have charge here minus q by 2 plus q. So this is equal to 0. So now we can calculate dipole moment. Now dipole moment P is equal to, first consider this charge, we will consider from the origin, from this point we will consider. So first charge is minus q by 2 and it is at distance, this is along y direction, so this will be minus of d y cap minus q by 2, and this is at distance dy cap, so dy cap, and this is at distance z, along z, so this will be q into distance is d z cap. So this will be, this will cancel out, so this will be, this is equal to 0, so this will be q d z cap, so that is dipole moment. Now v of r theta is equal to 1 upon 4 pi epsilon naught, then we have here p bar dot r cap upon r square. So this will be equal to 1 upon 4 pi epsilon naught. P bar is Q D Z cap, and this will be direction of R. So we are taking dot product with it. So this will be magnitude of P into magnitude of R cap is 1 into cos theta upon R square. So V is equal to 9 into 10 raised to 9. Charge is given. Charge is 10 raised to minus 6 coulomb into D, separation is 10 raised to minus 3. Theta is 60 degree. So cos 60 upon this distance R is equal to 10 meter. So this will be 10 square. So from here V is equal to 4.5 into 10 to the power minus 2, which is 0.045. So up to 3 decimal places 0.0425, and answer in the answer key is 0.044 to 0.046. So these were all the questions from GATE 2019 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.